Nvidia is not trying to build quantum hardware. We're not trying to build qubits. We're not trying to build a quantum processor, but we are trying to build a device that will turn those qubits into a useful quantum computer.
Nvidia just made a quantum leap, literally. The company has announced the Accelerated Quantum Research Center, NVAQC, a facility designed to merge AI, supercomputing, and quantum computing into one powerful system. This could be the breakthrough that finally makes quantum computing scalable and useful in the real world. In this video, we'll break down exactly how Nvidia plans to solve one of quantum computing's biggest problems, and why this could reshape industries like AI, finance, and medicine. But that's not all. Stick around, because we'll also reveal how Nvidia's new quantum approach stacks up against IBM, Google, and Microsoft in the race for quantum supremacy. The problem quantum computing faces. For years, quantum computing has been hailed as the future of technology. It promises exponentially faster processing, revolutionizing fields like AI, cryptography, and drug discovery. But there's one massive problem standing in the way: qubit errors. Unlike classical computers that use bits, zeros, and ones, quantum computers use qubits, which exist in multiple states at once thanks to superposition. This is what makes quantum computers powerful, but also incredibly unstable. The moment qubits interact with their environment, they pick up noise, leading to errors that make calculations unreliable. Scientists have spent years trying to fix this. Error correction in quantum computing is one of the hardest problems in modern physics. Traditional methods require running calculations multiple times, comparing results, and filtering out errors. But this process is slow and resource-intensive, making it nearly impossible to scale up quantum systems for real-world applications. So how do we fix this? This is where Nvidia's new research center comes in. The idea is simple, but groundbreaking. Use AI and supercomputing to handle quantum error correction. And this could be the key to finally unlocking quantum computing's full potential. How Nvidia plans to solve it. Instead of relying on traditional error correction techniques, which are slow and inefficient, Nvidia is integrating machine learning to tackle one of quantum computing's biggest challenges: qubit errors. By using AI, Nvidia can recognize and predict qubit errors far faster than conventional methods. These AI-driven corrections are then processed in real time by supercomputers, stabilizing quantum operations and making calculations far more reliable. The result? A massive speed boost for quantum computing, turning what was once an experimental technology into something practical for large-scale applications. At the center of this effort is the Nvidia Accelerated Quantum Research Center, NVAQC. According to Tim Costa, Nvidia's Senior Director for Quantum and CUDA-X, the facility will focus on three key areas: large-scale simulations of quantum algorithms and hardware, seamless integration of quantum processors with classical supercomputers, and the training and deployment of AI models to enhance quantum stability. This isn't just about developing another quantum chip. It's about solving the biggest bottleneck in quantum computing. If successful, Nvidia's approach could finally make quantum machines useful beyond theoretical experiments. And they're not doing it alone. Some of the biggest names in quantum computing are now part of this initiative. Nvidia's powerful quantum computing partners. The race for quantum supremacy isn't a solo effort. Even the most advanced tech companies can't build a scalable quantum system alone. That's why Nvidia has joined forces with some of the world's top quantum computing innovators, bringing together expertise from multiple fields to tackle the industry's biggest challenges. Some of the key players in this initiative include Quantinuum, Quera, and Quantum Machines. Quantinuum is a leader in quantum hardware and software development, working on advanced quantum processors. Quera is known for pioneering neutral atom quantum computing, a field that could make quantum systems more stable and scalable. Meanwhile, Quantum Machines specializes in building control systems for quantum processors, ensuring they can function efficiently in real-world applications. But Nvidia isn't stopping there. It has also partnered with Harvard's Quantum Initiative and MIT's Engineering Quantum Systems Group to bring academic expertise into the equation. This collaboration isn't just about building better hardware. It's about creating a fully integrated quantum ecosystem that blends AI, quantum mechanics, and supercomputing. Why does this matter? Because it shows that this isn't just an internal Nvidia project. It's an industry-wide effort to make quantum computing work at scale. And here's the real kicker. Nvidia already has the technology to make this integration happen, putting it in a strong position as quantum computing moves closer to real-world adoption. The game-changing tech behind it. Nvidia has spent years developing hybrid computing platforms, systems that bridge the gap between classical and quantum computing. Now, with the launch of its Accelerated Quantum Research Center, NVAQC, Nvidia is putting that technology to work in a way that could redefine computing as we know it. At the core of this initiative are two key tools, DGX Quantum and Q2Q. DGX Quantum is a hybrid platform that enables classical supercomputers to work alongside quantum processors, allowing for seamless integration between traditional and next-generation computing. Meanwhile, Q2Q is a software framework specifically designed to train AI models for quantum computing, making it easier to develop, test, and deploy AI-driven quantum applications. These aren't just theoretical projects. Nvidia has already deployed DGX Quantum in partnerships with quantum hardware companies, giving researchers the ability to run real-world quantum simulations at unprecedented scales. This marks a major turning point. Until now, quantum computing has been largely confined to research labs and experimental settings, but Nvidia's approach is making it scalable, practical, and ready for real-world applications. And if this works, the impact could be massive. Quantum AI has the potential to transform industries ranging from finance to healthcare, solving complex problems that were previously impossible for even the most powerful supercomputers. But before we dive into how this could reshape the world, there's something else we need to address. Nvidia isn't the only company in the race for quantum supremacy. What this means for the future. If Nvidia's AI-powered quantum computing succeeds, it could mark one of the most significant technological shifts of the century. This isn't just about making computers faster. It's about unlocking entirely new capabilities that traditional computing simply cannot achieve. From AI development to drug discovery, quantum computing could revolutionize industries in ways that were once thought impossible. One of the biggest transformations could happen in AI training. Right now, training large-scale AI models like GPT-4 and beyond requires enormous computational power. Even the most advanced GPUs struggle to keep up with the increasing size and complexity of modern AI systems. But with quantum AI, neural networks could be trained exponentially faster, accelerating progress in machine learning, natural language processing, and autonomous systems. The pharmaceutical industry could also see groundbreaking advancements. Simulating molecular structures and protein folding is one of the most computationally demanding tasks in drug discovery. Quantum computers, combined with AI, could analyze entire chemical reactions at an atomic level, leading to faster drug development, new treatment discoveries, and even personalized medicine tailored to individual genetics. Another critical area is cybersecurity. Quantum computing poses a serious risk to traditional encryption methods like RSA, which could be broken almost instantly by a powerful enough quantum machine. However, Nvidia's AI-driven quantum approach could help develop post-quantum encryption, ensuring that data remains secure even in a world where quantum computers can crack existing cryptographic systems. Beyond security and medicine, climate modeling is another field that could benefit significantly. Quantum simulations have the potential to analyze climate patterns with extreme accuracy, helping scientists make better predictions and mitigate the effects of climate change faster than ever before. In finance, quantum computing could take real-time market analysis to another level. Banks and hedge funds already use AI for predicting stock trends and managing investments, but quantum algorithms could process billions of market variables simultaneously, optimizing financial strategies with unprecedented speed and accuracy. Institutions like NASA, IBM, and Google are already investing heavily in quantum research to tackle these exact challenges. However, Nvidia's unique approach, integrating AI, supercomputing, and quantum into a single, scalable system, could be the missing piece that finally makes quantum computing practical for large-scale real-world applications. The race for quantum supremacy. While Nvidia's announcement is groundbreaking, they are far from alone in the race for quantum supremacy. Some of the biggest tech giants are already deep into quantum research, each taking a different approach to dominate the next era of computing. IBM has been at the forefront of quantum computing for years. It was one of the first companies to build a functional quantum computer, and its Quantum System 1 is designed to push commercial quantum computing into mainstream applications. IBM has been steadily working on increasing qubit stability and reducing error rates, making quantum systems more viable for real-world use. Google, through its Quantum AI division, made headlines in 2019 when it claimed to have achieved quantum supremacy, demonstrating a quantum computer solving a problem in seconds that would take classical computers thousands of years. Since then, Google has continued refining its quantum processors with a focus on fault tolerance and scaling up qubit counts. Microsoft is taking a different approach by investing heavily in topological qubits, a theoretical type of qubit that could be far more stable than conventional quantum bits. While Microsoft's quantum hardware is still in development, its Azure quantum platform allows businesses and researchers to experiment with quantum algorithms in the cloud. So where does Nvidia fit into this competitive landscape? The key difference lies in Nvidia's focus on AI and hybrid quantum computing. While companies like IBM and Google are working on standalone quantum processors, Nvidia is building the infrastructure to seamlessly integrate AI, supercomputing, and quantum computing into a unified system. This hybrid approach could give Nvidia a unique advantage. Most industries aren't ready to switch to pure quantum computing yet, as the technology is still in its early stages. But by bridging quantum with classical computing and AI, Nvidia is creating a transition pathway, allowing businesses to start benefiting from quantum power without waiting for full-scale quantum machines to become commercially viable. The next steps. Nvidia's Accelerated Quantum Research Center, NVAQC, isn't just a research facility, it's a launchpad for large-scale quantum AI development. Starting in 2025, the center will run quantum simulations to test how AI and supercomputing can improve error correction, a major hurdle in quantum computing. Nvidia is also expanding partnerships, bringing in universities and private companies to speed up progress. If Nvidia successfully integrates quantum processors with its DGX quantum platform, real-world applications could emerge sooner than expected, impacting AI, cybersecurity, and scientific research. While full-scale quantum computing is still developing, Nvidia's AI-driven model could make quantum power accessible much earlier than predicted. The quantum future is here. Quantum computing is no longer just the technology of the future, it's happening now. With Nvidia's advancements, AI, supercomputing, and quantum mechanics are converging faster than anyone expected. Do you think Nvidia's hybrid approach gives it an edge over IBM, Google, and Microsoft? If you've made it this far, let us know what you think in the comments section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.